Okay, can you hear me? Can you hear me, please? Let me know. Okay, great. So let's get started. So we have Abdullah, Agandi, Muhammad, Ben, Rawa, Aaron, William, Chris. Let me see. Is Monica here? Yes. Very good. All right. So I think everyone is here. Is Casey here? No. Okay. All right. So wait a minute. Okay. So I have finished grading D1, and I give you feedback already. Okay. Make sure that when you demonstrate your design, you can see the screen clearly, and also I can see you in the video so that I know it's you. It's not somebody else. Okay. All right. So today we'll continue our lecture about um, the BMP file on SD card. Right? And if you look at what we've done so far, we have developed programs to extract the size of a BMP, to extract the pixel data from a BMP, and then to reduce the pixel data from 24 bits to 8 bits using our program. Okay. Right now, the way we checked our program is to look at the terminal of Arduino. So we'll print everything to the terminal. Okay. Our next step is to put the information you extracted about the pixel data into a file. Okay. So if you look at this file, which I give you as a D1 sample, look at it. It's a cluster of, or a block of red, block of green, and block of blue. Same size. The width of the image is 16 pixels, and then the height is 24 pixels. Okay. And from our previous program demonstration, we found that the BMP is stored not as RGB but BGR. Okay, and 24 bits. 24 bits. Our program will extract the data, will convert it into VGR 8-bit. Okay, and also instead of presenting as VGR, we revert the order and fix it to the RGB. Okay, so for 24 bits, it's 8, 8, 8. 8 bits for blue, 8 bits for green, 8 bits for red. For program process data is 3 bits for red, 3 bits for green, and 2 bits for blue. Why are we doing this? Okay, because eventually we're going to take this information, feed it into a C program, run it on the Neos 2 system, see the result on the VGA. Any question? Okay. Okay. All good. That's great. Now, BMP pixel data is stored as one dimensional or 1D array because it's a file. There's no two-dimensional array in the file. A file start from the first byte, just keep going to the second byte, the third byte, and then eventually we'll hit the end of file. But VGA pixel data is 2D array. Okay. Remember, VGA has horizontal, has vertical, so it's a two-dimensional array. And when you program C on Neos 2 system, you have data stored in 2D array, and then you display it on VGA. Okay? Understand? So in design assignment number 2, D2, we are going to present the data from a BMP to the screen so we can visually check it to make sure that our new processing is correct. Okay. Then we are going to look at the data and put them into a file. And the format we have chosen is a C format, C syntax. Okay. Remember, it's C, not C++, C syntax. Okay. All right. Then we can use this data in the file and then just put it into a program and then run the program. You should see everything on the screen. Okay. All right. So the process is BMP Arduino program, which generate the BMP pixel data 8 bits to a file. Okay. And eventually, you can take this into a Neos 2 VGA display. Okay. So now we were here. This is D2, this is D3, and this is D4. Understand? So Let's do this D1. I keep saying D2, D2, D3, and D4. Okay. Okay. So now I'm going to show you a demo to see how it works. So now I'm going to present this data onto the terminal and show you what the expectations are. Okay. Now before we do that, let's manually convert this data to make sure that we understand the expectation. Okay. First, you need to understand this is pure blue, pure green, pure red. Vertically, it's 8 pixels. Horizontally, it's 16. So you have 8 plus 8 plus 8, 24. Understand? Okay. Now before I start going into the detail about the conversion, any questions? Okay. All right. Good. Let's continue. Now the image itself is stored upside down. So that means when you start reading the data, you're not going to see the red first. You're going to see the blue. So this is D1 sample dot BMP. I think it's BMP. Okay. So you're going to see, remember it is BGR, then BGR, then BGR. Okay, so this is 1 pixel. Now we know it is pure blue. That means you're going to see BGR is blue FF, green 0000. Next pixel, F F 0000. Okay, let's maximize this. And you're going to see 16 of these. Now I'm showing you 2 pixels. This is 4, 6, 8, 10, 12, 14, 16. Okay. Unfortunately, it doesn't fit my screen, but you get the idea. And there are a total of 8 rows because you get 8 pixels in height. Okay. So that means you have 1, 2, 3, 4, 5, 6, 7, 8. So this section is the blue, right? This is blue BGR, 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 BGR. So this is how it looks in the file. It's continuously. Okay. And then after the blue is the green. So the green is no blue, green, no red. Okay. And then this is 1 pixel, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 pixels in a row. And 1, 2, 3, 4, 5, 6, 7, 8. 8 pixels vertical. Okay. Then the last section will be the red, pure red. Looks like this. So this is 1 pixel. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Similarly, you get 8 of them. 4 rows, 5 rows, 6, 7, 8. So this is everything. all the pixel values. All right, so far so good. Please let me know. Okay, great. So how to do the conversions? So let's take this conversion. Blue, green. This is 24 bits. So after converting the blue from 24 bits into 3 bits, what the value should be. Everything is in hexadecimal. Can anybody give me the value for blue after converting into 8 bits? If you know the answer, please type it in the chat room. Okay, Muhammad, are you typing in hex 32? Okay, so this is blue. So after conversion, it should be 3 bits red, 3 bits green, 2 bits blue. Okay, so let's type it in here. Red, there's no red, so it's 0, 0, 0. There's no green, and this is 100% blue. Okay, or this is what you should get. This is RGB 3 bits, no red, all the green, no blue. So what is this value? 0001 and 1100 is equal to 1. This is C. Okay, last. So this one, please work on it and let me know the answer. This is the red. correct? 111 means all the red, no green, no blue. Okay? Alright, so now if you look at this whole thing, if you look at what we did a conversion for 1 bit. Since all the bits are the same for green section, for blue section, for the red section, you only need to do it once. But a real image may not be like this. They have different values for each pixel. So I'm going to retype this whole thing here using. Okay. So now after all the conversions, 8 bits. So the blue is 03, 03. So this is 1 pixel. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And you have 8 of these, right? Okay. And the green is 1C. Okay. And the last is E0 for the red. So this is how it looks. You have E0, 16 in a row, 8 rows for the red. Okay. Right. Now if you are going to join this together, you expect to see this on the screen. Any questions on how we got these values? So besides Aaron, anybody else has questions? Okay. All right. So the assignment requires you to display the values upright, not upside down. So that means this whole thing will be upside down. So this is D1 sample dot BMP 8 bits upright. Okay. So we're going to see the red first, and the green, and the blue. Okay. So it was following the format of the file, which is upside down. So when we process them, eventually we want to present the values in the upright position. Otherwise, it's very confusing when you see on the screen. Okay. Okay. All right. Can everybody see my screen? You see my screen? Yes, no? Okay, let's continue. Alright, so I'm going to show you a demo right now that will show this information on the screen based on this value. The demo I give you, sorry, the file I give you for the demo is not this file. This is only for you to do development. Okay. Alright, so now I'm going to do is I'm going to bring up the terminal and show it to you. Okay. I'm waiting for the TC. Yes, here we go. Okay. So now, look at this. This is what we're talking about. See all these values. Okay. This is the upright position. Okay. Starting with the red, then the green, then the blue. Okay. And also show you, just for information only, it was upside down before. It was these values for the red, and then the green, and then the blue. Okay. Now this is easy to interpret because all the values are uniform. But for real file, it's going to be different. Okay. To test your program, you'd use something to easily interpret for interpretation. For real, it's not going to be like this. You see other values, not just 3, not just E0, not just 1C. You see them, but there could be other values. Understand? So for D2, this is what I expect from you. Any questions? Yes, D2. D1 was already over. D2, you need to display the values on the terminal like this. 0, 3, 1C, and E0. So if you run your program, yes, if you run your program, if you see this on the screen, that means you can process sample D1 samples properly. Yeah, it is two-dimensional. Look at X and Y. Yeah, it is two-dimensional. You see, you get a horizontal, then you get the vertical. It's two-dimensional. Okay, so two-dimensional. All right. Any questions before I move on to the next topic? Okay, no question? That's great. Let's move on. All right, coming back to this. Now, why is this important? Is because in Neo's tool system, the VGA is 2D. Okay, you need X, which is horizontal, then you need Y, which is vertical, to display everything on the screen. When you write a program to work with the VGA, you want to store your information, in this case, in a 2D array. That's the easiest way to do it because the screen is already 2D. You store everything in 2D. Okay, so the VGA is 2D. Your pixel data is 2D. Okay. Then what you can do is you can easily develop a an efficient way of displaying data on the screen. Okay. So what I'm trying to say is, if you use a loop, okay, or loops to program VGA display. Okay. So if you look at this data that I'm showing on the screen now, this is already in a two-dimensional array. Okay. Of course, this is not a C syntax. This is just some numbers we converted. Okay. You are going to display this as starting from here, put it on the screen. Go to the next row, next column, put on the screen. Go to the next column, next column, next column. When you finish with the last column, you're going to go to the next row and repeat the process. And this process is bounded by number of columns you have and number of rows you have. So that means you write a loop to do this action from left to right display. Then you write another loop to do vertical from first row to second row to third row, fourth row, and then all the way to the end. Okay, so you need to have one loop, same row from left column, I'll say column 0 to column n, another loop, same column, next row. Okay, so you're doing this left to right, then top to bottom operations. If you're smart, you can combine two loops into nested loop. So loop number 1 will do horizontal or vertical. Which one should happen first? And after loop number 1, there's a loop number 2. Think about the action. It's left to right first, then top to bottom, right? So that means you must display column 0 to column n on the same row. Okay. And this will display next row, right? So now when you try to display anything, what you need to know is, where do you store the data? It is in two-dimensional array. What's the limit of the array? Now we know the limits is your screen. Okay? Yeah, that's right. This is vertical, and this is horizontal. Okay? When you program in C for the Neo system, the Neos 2 system, what you do is you create this nested loop structure. You know the boundary. Okay? You know the boundary of the data you want to show on the screen. Okay? Then you finish one row at a time, then you go through all the rows when you finish everything. Okay? Now the only thing that's right now is unknown is where do you put it. Okay? And you have this big piece of data you want to put on the screen. You know the size, X and Y, but where do you put it? Okay? This is something that you need to think about is you want to put this bunch of data on the screen. How does the location on the screen affect your loop? So the question for you to think about is, how does position of 2D array on VGA changes the loop? Change the loop. Nested loop. Okay? So this is something you need to think about. Okay? Because you can put it at a corner, you can put it at this location, you can put it at that location. You need to think about this. Understand? So far, any question? Anybody else besides Aaron? Okay, that's great. So everybody is all set. So now what you need to do is, well, I don't care what you did before in previous classes. For this class, we'll work with the Neos 2 system, VGA. I expect the data that you presented is saved in a two-dimensional array. Understand? Because the code that you're going to use to display on the screen is going to be this structure. Okay, so I'm looking for a specific implementation. Okay, no hard coding anything. The data is always in a 2D array. Okay, and when we start working towards the project, we're not going to hard coding anything manually into the data for the pixels. Everything will be extracted using your Teensy 3.5 program. So we have the files, then you extract the information, automatically generate everything. Then you don't need to type in anything specifically. Okay, but we'll get there eventually. All right. At this point, any questions? No? Okay. So, so next thing I'm going to show you is if you want to put this information onto a file like this. This is the file. How does a file look like? Okay. So that will be D, which one is it? D3. So I just show you about D2. You show everything on a terminal. What about you put it on the file? Okay. So I'm going to run my program, the Arduino. Then I'm going to plug in the SD card, and then I'll let you show you how the file look like. Okay. So I just reran the program on the Arduino. Before you unplug the SD card or plug in the SD card, make sure that your Arduino is disconnected from power. Otherwise, you may corrupt the SD card easily. Okay. So now I'm going to plug in my virtual machine, the SD card, and I'm going to see the file. Here it's my file. So you look at this, is what I have. I have some comment. Okay. If you put your name on it, otherwise I don't know if it's yours. And then it generates a two-dimensional array, vertically 24, horizontally 16, so 24, 16, and initialize the values with the data extracted from the file. Okay, and this is not upside down, this is upright position. And this is the syntax for C. Okay, this is C syntax. Okay? So everything in hexadecimal. You can use decimal, but it's not really readable. I should say readable. Understand? Okay. So for D3, I expect you to do this. So I give you a file with whatever size. There will be a limit, maximum size you can process. Okay, and then you run your program. You can figure out, okay, this is the size of the file. So this is the size of the image file, X and Y. Then you extract data automatically, put in from 24 bits into 8 bits, and then put it into a file. In this case, I use a text file. And then on the text file, you are going to create the two-dimensional array that contains the data for the BMP image, whatever size the image is. So for example, if I give you 100 by 200, you're not going to come in here and start typing in 100, 200. Then you can run it, then you can see the data. Okay, then I can look at your output and compare to the correct outputs, and I can see if your program works. Okay, so to develop your code, you always use something that's simple. For example, D1 sample. We know the size, we know what's in it. When you run it, it's not too big. You can still manually inspect the values. But once you feel comfortable this is working, you can try bigger data. Okay, to prove if the data you have extracted are correct, put this on the screen, then you can see whether it works or not working. Understand? So that's our goal for 1, 2, 3, 4, D1 through D4. Any questions? that's great. Um, so before we finish today, any questions about D2, which is due this week? Any question on D2? Good. Okay. Um, Remember, we have a textbook for this class, which is a self-paced, tutorial-based textbook on making PCBs. So I assume that you have been reading the textbook because starting assignment number 5 and 6, you'll be doing that. Okay, and the software described in the textbook, it's a free software you can download. Okay, they give you a what they call a student edition or limited edition where you can install in Windows. I believe it's Windows only. I could be wrong. It could be there could be a Mac or there could be a Linux version. So and then if you go through a textbook, it shows you how to use the software step by step. Okay, each chapter of the textbook shows you a few features in the for the software. Okay, so please work on it because when the assignment comes, you're not going to learn this overnight. Okay? It takes some time to understand how to create schematics and then how to create PCB for the schematic. Understand? It is not a lecture-based textbook. It is a self-paced, tutorial-based textbook. If you have not obtained the textbook, no problem. You can go to Amazon or any online store. You can get an e-copy. Or you can get a paperback copy. Um, I think for secondhand, the book costs you I think $20 or could be less. Okay. Okay. So what you need to do, go home, is to think about this question and look at how to structure the loop. Okay, because in D4 this will come in and then you need to do it. Okay, and because of this type of work is VGA based, I want to see demonstration. Okay? Not only video of demonstration. I'll give you a file when the class starts, and I want you to process it right away. So I give you the class time. Here's a file. Run it. Run your program. Show it to me it works, and then upload the video. So that's a live demonstration. Okay? Unfortunately, I cannot see your video live streaming, but I can see the live video taken during the class time. Understand? So the first few, I let you know, record the video at a different time and upload it because those are simple. Okay? But for these more complicated ones, I want to see a live demonstration. Understand? Okay, if you do not have any more questions, you can exit the live. If you need my support looking at your computer, send me the code. Otherwise, I'll terminate the stream in 2 minutes. Okay? These notes will be available on DualLearn later today, but the recording won't be available until tomorrow because YouTube doesn't give it to me until tomorrow. Okay? The video usually it's available within like probably 24 hours, so I assume that close to noontime they should be available. But whatever they're available, usually I just process them right away and post on the channel. So check in the morning and check in the afternoon. Either morning or afternoon they should be available. I assume it's in the morning. Okay? Because usually they tell you 24 hours, but it doesn't really take 24 hours. Yeah. Well, the nice thing about this live stream from YouTube is that it records all everything we did, and then you can always go back and watch. Now, this is different from a in-classroom lecture where it's very interactive. I wish they can do like a two-way audio between me and the class. Unfortunately, I don't think that's possible. And there may be a different platform for you to use to do this. The nice thing about this, it records everything. It records my screen. You can see my screen. You can see the demonstration live. Okay. Okay. Yeah. If you don't have any questions, I'm going to terminate the YouTube live in 1 minute. Okay. Yes, we will go back to class, but not this time. Next time we'll go back to class. Don't worry, this thing will be over soon. Okay. Okay. I'm gonna terminate the YouTube live now.